When we look up at the starry sky, it is hard to imagine that hidden among the myriads of stars are objects that could be the basis of the space economy of the future. Asteroids are not just rocky debris floating in space, but true treasure troves containing metals, water, and other resources that can be used to propel humanity into deep space. Today, we will delve into the world of asteroids and explore their potential as a source of resources for future generations. What are asteroids? Asteroids are small celestial bodies, mostly composed of rock, metals, and ice. They range in size from a few meters to hundreds of kilometers in diameter. Most asteroids are located in the main asteroid belt between the orbits of Mars and Jupiter, but many cross Earth's orbit or are located beyond the orbit of Neptune. Classification of asteroids. C-type carbonaceous. Contain carbon, water, and organic compounds. These asteroids are the most common and are especially interesting because of the presence of water. S-type silicate. Composed of silicates and metals such as iron and nickel. M-type metallic. Rich in metals, including rare platinum groups. Research shows that asteroids are remnants of the material from which planets formed, and studying them can shed light on the history of our solar system. Asteroid resources. Metals, from iron to platinum. One of the most valuable finds on asteroids are metals. For example, M-type asteroids contain nickel, iron, iridium, platinum, and gold. Some of them, such as Psyche, are composed almost entirely of metals. Just one such asteroid may contain more metals than have been mined in human history. Water, the key resource of space. The water contained in carbonaceous asteroids could be a crucial resource for space missions. It could be split into hydrogen and oxygen, the main components of rocket fuel. This would enable space refueling stations and significantly reduce the cost of interplanetary travel. Applications of water. Fuel production. Life support, drinking water and oxygen. Radiation shielding. Rare elements. Asteroids can be a source of rare elements such as lithium, cobalt, and platinoids, which are used in the manufacture of electronics, batteries, and other technologies. Asteroid mining technologies. Finding suitable asteroids. The first step in mining resources on asteroids is to select a target. Using telescopes such as NEOISE and spectral analysis, scientists can determine the composition, size, and orbit of asteroids. Programs such as Breakthrough Listen help track objects closest to Earth. Mining methods. Optical mining, using sunlight to heat the surface of asteroids and extract volatile substances such as water. Surface mining. Collecting materials from the surface using automated manipulators. Underground mining. Using drills and robots to extract resources from the interior of asteroids. Microgravity problems. Due to the low gravity on asteroids, traditional mining methods are not suitable. Therefore, companies are developing special systems such as harpoons and anchors to anchor themselves to the surface of asteroids. Economic potential. Space economy. Asteroids could form the basis of a new space economy, providing resources for building satellites, space stations, and colonies. Water and metals could be used to build infrastructure right in space, reducing dependence on shipping materials from Earth. Private companies and governments. Companies such as SpaceX, Blue Origin, and TransAstra are actively developing technologies for resource extraction. Luxembourg was one of the first states to establish a legal framework for resource development on asteroids. Comparison with the gold rush. Many experts compare the potential of asteroids to the gold rush of the 19th century. While gold attracted thousands to the Wild West, asteroids could be the next frontier for adventurers and investors. Science missions. Hayabusa and Osiris-Rex. Japan and the US have already sent missions to study asteroids. For example, NASA's Osiris-Rex mission delivered samples from the asteroid Bennu to Earth. These samples help scientists study the composition of asteroids and develop methods to explore them. Psyche. NASA is planning a mission to the asteroid Psyche to study its metallic surface. This mission could open new horizons for understanding the formation of planets. Ethical and legal issues. Ownership. Who will own asteroid resources? International treaties, such as the 1967 Outer Space Treaty, prohibit nationalization of celestial bodies, but the question remains how to distribute the extracted resources. Environmental implications. Mass mining on asteroids could lead to unintended consequences, including lower prices for rare metals and possible changes in Earth's economy. The future of asteroid mining. Refueling stations. Asteroids could become intermediate refueling stations for spacecraft. This would simplify deep space exploration and make missions to Mars and beyond possible. Colonies on asteroids. Some asteroids can be turned into space bases. Their low gravity and wealth of resources make them ideal for establishing autonomous settlements. Economic transformation. If resource extraction technologies are successfully developed, it could completely change our view of the limits of human endeavor by making space available for business and science. Asteroids offer unique opportunities for humanity. They could become the basis for a new era of space expansion, providing resources for the exploration and development of the solar system. However, their exploration requires the resolution of many technical, legal, and ethical issues. If these challenges are overcome, asteroids could be the key to humanity's future.
I believe that resource extraction on asteroids is not only science fiction, but a necessity that will become a reality in the coming decades. The main challenge we will face will be to create technologies that can make this process economically viable. However, the opportunities that will open up for humanity will far outweigh the challenges. Utilizing asteroid resources could not only accelerate space exploration, but also reduce the strain on the Earth's ecosystem. This is not just a step forward in science, it is the way to a new chapter in human history.